Okay, class. So today we're going to talk about the Poisson distribution. I was born in Florida, so I like to watch the news whenever hurricanes are going to show up, and we're always worried about when is the likelihood of a hurricane actually coming on to U.S. shores, right? When is the likelihood of us actually having an event where we have to worry about hurricanes affecting the U.S. coastline? And so what we have here is a website from the Hurricane Research Division of NOAA, and we have the history of hurricanes for as far back as we have collected information. So this is everything from 1851 straight on through 2015. We can see the total number of hurricanes that have come through, as well as all tropical storms and things like that. And what we're going to do just for this example is treat the number of hurricanes as a Poisson distribution. All right, we're going to treat the number of hurricanes as a Poisson distribution. We're going to see here that the number of major hurricanes, to keep the counts low, all right, is going to be this third column. And this third column has an average of 2.4 major hurricanes with a standard deviation of 1.7. Now, hopefully one of you can tell me why this isn't a perfect measure of a Poisson distribution given this mean and this standard deviation. But anyway, we're going to look at what is the likelihood of seeing two or more major storms. So if our mean, meaning the number of storms in a given set of time, 1 year, is 2.4, I want to know what is the probability of having two or more hurricanes in a given season. So to do that, we're going to go over to Excel. And we open up the Excel feature here. And what we want is the Poisson distribution. So I'm going to blow this up so that we can actually see what's going on in the cell. All right. Come back out here. And I'm going to say this is equal to Poisson distribution, where I want it to be two or more. But since this is a discrete distribution, I really need to put 1 in here first. I'm going to put in my mean of 2.4. All right, my mean of 2.4. And at the very end, I want to either put true for a cumulative distribution or false for a probability mass distribution. If I put false, this will return the probability of having only one major storm. If I put in true, it's going to be the probability of having one major storm or less, which in our case would be 1 or 0. So I'm going to put in true. And the reason is I want to know 2 or more. So when I get this result, I see that about 31% of the time we're going to get one major storm or less. But I want to know if it's 2 or more. In order to get the or more portion of it, I have to do equal to 1 minus this amount. Which means that in any given year, there is a little bit more than a 69% chance that we'll have 2 or more major hurricanes in the Atlantic Basin. And you can see it's very easy to do. We can find actually exact probabilities just by plugging in values. So let's say we want to find out what is the likelihood of there being 5 major storms. All right, so 5 major storms. We're going to put in 5 for X. We still put in the same mean of 2.4. In this case, we want to know exactly 5, so we're going to put in false. And the likelihood of 5 major storms in a given year is going to be around 6%. This is an easy application of the Poisson distribution. Again, Send me an email. Let me know why it's not a perfect Poisson distribution, looking back at that mean and standard deviation. And I'll consider some extra credit later on down in the course. And that's it. Take care.